you can join us.
Okay, so let's talk very briefly about the lab, okay? Looks like you guys got some pretty solid data. So you started off, and here's the whole idea. There's two assumptions that you're gonna make. Number one, most importantly, is that the surface is frictionless. So once that cart expands and it rolls, you assume that the velocity remains constant, which is why that pre-lab graph looks something like this, okay? So this is when that plunger was exploding, okay, pushing back, right? Then this is when it's rolling along at a constant velocity. So here's the bigger idea. If your velocity time graph is a horizontal line, that means your momentum time graph is going to mirror that, okay? Okay? So if your velocity is constant, your momentum is constant. If your velocity is changing, your momentum is changing, okay? So remember, if this is a momentum time graph, so that's Newton seconds and that's seconds. So if you were to find the slope of that, that would be Newton seconds per second. Seconds cancel out, boom, you get units of force. So the slope of a momentum time graph, there's one important word in there. That gives you net force, okay? Not force, it gives you net force. So when those carts were rolling, gravity was pulling it down, the track was pushing it back up, there were forces acting on it, but it just wasn't changing the momentum, okay? So, the second assumption that you make is that the only time the momentum changes is when that spring expands, because that's the only time there's an imbalanced force acting on the system. So hopefully what you should see is that your forces should be relatively equal and opposite. What did you guys get for your forces?
I got negative 20.25 newtons for the first cart. In cart 2, I got 22.75.
So about negative 20 and about positive 22.
Yeah.
Okay, that isn't horrible, all right? Okay, it's not bad. Pretty close, okay, with what you were measuring and the data that you had. I can live with that. Okay. On number 8 on the back, where you're going to tilt that ramp a little bit, okay, not much, you're going to tilt that a little bit. And what's going to be important about on this one is that the more massive cart has the positive velocity. So, and that's the one that's also going up the hill. And you're told, labeled the point where the more massive cart changes direction. So imagine here's your two carts, okay? This one has that more massive one on it. And that spring is going to expand. So what I've given you is the beginnings of the graph, okay? That should be the steepest portion of this. Don't, like on this bottom one, don't take that same line and continue it down, okay? Don't. Because this is that very rapid expansion when the plunger is expanding, okay? So if you think this slopes down, great. Just don't keep that same slope, because then you're going to say, oh, it's going to have the exact same downward acceleration as when that plunger was expanding, and it's not, okay? So this, let me give you a hint. This slope on this bottom one should be pretty shallow, okay? So what you have to decide is, does it slope up or does it slope down? That's what you have to decide. Now, what you have to decide on the top one, you have to make 3 decisions on that. Does it slope up? Does it slope down? And if it does slope down, is the line parallel with the bottom one, or is it more shallow, or is it less shallow? Okay? So that's what you have to decide. So on that top line, you need to decide, does it slope up? Does it slope down? And if it does slope down, is it the same slope as the bottom one is? Okay, that's your decision. On number 2, you should see the same numeric answer again and again and again. Okay, signs are going to be different, but you should get the same numeric value. On number 3A, because if 3A is wrong, everything is going to be wrong. So your answer to 3A should be a little bit less than 2 meters per second. Okay? Because if that's wrong, everything's going to be wrong. Now, let me give you a hint on F. What is the change in momentum of the bullet if it ricochets off in the opposite direction? So that's what we just talked about. So instead of this bullet hitting and embedded in the block, it's going to hit and it's going to bounce back. Okay? So if something hits and changes direction, what do you know about the sign of the velocity?
G.
Keep that in mind. So, any other questions on the lab? We're good? Going once, going twice. So make sure somebody hands in that pre-lab graph to staple that to somebody's lab, make that like the last page. And then, y'all know the drill after that. So Vanessa, stop you on the camera.